Ever had one of those days where the power goes out and suddenly, you can't even remember what you were doing?
It's crazy how much we rely on electricity.
Totally. It's like our entire world just stops. So today, we're going to dive deep into how they actually keep those lights on, specifically when it comes to power grids.
And get this, we're looking at how this really cool tech, machine vision, is totally changing the game.
Machine vision. All right, I'm listening.
Well, it's fascinating how much we depend on something we rarely even see, the power grid itself.
True. Out of sight, out of mind, right? Until the lights go out, that is.
Exactly. And here's the thing, with the rise of electric cars and even people generating their own power, those lines are getting more and more strained.
Especially those massive high-voltage towers you see crisscrossing the countryside, right?
Actually, those are important, but we're focusing on something a little different today. We're talking about medium voltage networks.
Medium voltage. Those are the lines connecting neighborhoods and businesses, right?
You got it. They're like the capillaries of our electrical system.
Okay, so instead of the big highways, we're talking about the side streets where the power actually gets delivered.
Precisely. And here's the kicker. A whopping 90% of power outages in distribution networks actually originate in these medium voltage networks.
Wow, 90%. Seriously, I had no idea. But something tells me inspecting these networks isn't as easy as, just glancing out the window.
You're telling me. Imagine relying on someone in a helicopter to spot a tiny crack in an insulator from hundreds of feet in the air.
Yeah, that doesn't sound very efficient.
Not at all. This Finnish power company we're looking at, Järvi Suomen Energia, they have over 28,000 kilometers of lines to monitor.
28,000 kilometers. That's a lot of power lines.
It's like flying back and forth across the entire United States, and they're doing it all manually.
No wonder things get missed.
Yeah.
So how does machine vision help us move beyond these kind of old school inspections?
It's all about giving computers a set of eyes, allowing them to actually see and analyze images just like we do.
Okay, so instead of relying on humans to spot every little thing, we're teaching computers to do it for us.
Exactly. Imagine teaching a computer to spot a frayed power line with the same accuracy as a seasoned lineman, but on a massive scale and without needing a break.
Okay, let's unpack this a little. We're talking about training a computer to recognize potential problems in the grid, right?
Yeah.
How does that actually work? So we're basically training computers to be like master electricians, scanning the grid for any sign of trouble. But the real world is, well, messy, right?
It's definitely not as simple as inspecting a clean circuit board.
Yeah. Power lines run through forests, over mountains, across busy streets. How can a computer possibly make sense of all that?
That's where things get really clever. The company we're looking at today, Uvision, they've developed this two-pronged approach: reliability prediction and vegetation prediction.
Okay, a two-pronged approach. What does that even mean?
Think of it like having a team of detectives working the case from different angles.
I like the sound of that. Tell me more about these detective teams.
So the first team, the reliability prediction crew, they're like data detectives.
Data detectives?
Yeah. They spend their days poring over years of the network's history, looking at things like past failures, equipment age, even weather patterns.
Wow, so they're looking for clues buried in all that data.
Exactly. By finding hidden connections in all that data, they can actually predict which parts of the grid might be more prone to problems in the future.
So it's all about spotting those red flags before they become actual fires.
Right, got it. It's like preventative maintenance on a whole new level.
Okay, I'm really liking the sound of these data detectives. What about the second team, the vegetation prediction folks? How do they operate?
They're more like the high-tech scouts. They use laser scanning to create a super detailed 3D map of the entire network and its surroundings.
3D mapping. That sounds pretty sophisticated.
It is. Imagine like a street view, but instead of just seeing your house, you're seeing every branch and every leaf that's growing near the power lines.
And I'm guessing they can tell when those branches are getting a little too close for comfort, especially with those high winds we've been having lately.
Exactly. This component can identify areas where vegetation poses a risk, allowing for like proactive tree trimming before those branches cause an outage.
So it's all about preventing those, well, there goes the power moments, especially during like storm season.
You nailed it. No more waiting for a tree to fall on a line. They can address the problem before it even becomes a problem.
This is all starting to sound incredibly precise. It's one thing to say, hey, this part of the grid seems a bit risky, but it's another thing entirely to like pinpoint the exact location and type of potential issue.
You're absolutely right. It's not just about vague warnings. It's about giving power companies actionable insights.
And that makes a huge difference when it comes to actually fixing problems, right?
Absolutely. I mean, knowing whether you're dealing with a faulty transformer or a cracked insulator, that level of detail helps maintenance crews prioritize their work and minimize downtime.
Okay, so it's like having a personalized to-do list for the entire power grid. I'm sold. But how does a company like Evision actually put this technology into practice?
Well, they wouldn't just like dump a bunch of data on a power company's doorstep and say, good luck with all this.
So they don't just show up with a flash drive and disappear.
Yeah.
So they don't just show up with a flash drive and disappear.
Definitely not. They're all about a more hands-on approach.
Hands-on how?
Well, they usually start with a pilot project.
A pilot project.
Yeah, they focus on a smaller section of the network first, maybe a few hundred kilometers of lines.
So it's like a trial run.
Exactly. It's a way to demonstrate the technology's value without, disrupting the entire system right from the get-go.
Makes sense. So a bit of a try before you buy
Mm-hmm.
situation for the power companies.
Precisely. And during this pilot phase, Evision works closely with the client to fine-tune things.
What kind of things?
Oh, like figuring out what kind of issues are most important to flag and how sensitive the algorithm should be, that sort of thing.
So it's about tailoring the system to their specific needs.
Exactly. Think of it like calibrating a high-tech instrument to make sure it's giving the most accurate readings possible.
Okay, that makes sense. And if the pilot project is a smashing success, what happens then?
Well, that's when things get really exciting.
How so?
They can then expand the system to cover the entire network.
Wow, the whole thing.
Whole thing, providing continuous monitoring and analysis.
So the computer is basically keeping an eye on things 24/7.
Exactly. And here's the best part. The model doesn't just sit there statically. It's constantly learning and adapting as new data comes in.
So it's like having a team of expert electricians working around the clock. But instead of needing coffee breaks, they just get smarter with each passing day.
Exactly. And on top of all that, all of this information is accessible to the power company through a user-friendly online platform.
Oh, so they can actually see what's going on.
Oh, yeah. They can see the health of their network visualized in real time.
Wow, in real time.
Yep. Identify potential problems before they become outages and make data-driven decisions about maintenance and upgrades.
Now, that's what I call taking control.
Yeah.
We've gone from relying on someone spotting a problem from a helicopter to having this, like, crystal clear, constantly updated view of the entire network.
It really is remarkable when you think about it.
It is. It's mind-blowing. But it sounds like this is about so much more than just fancy technology. It's about building a more resilient and reliable power grid, right?
Absolutely. It highlights how technology like machine vision can revolutionize essential infrastructure like power grids.
And hopefully lead to fewer of the days where we can't even remember what we were doing because the power went out.
Exactly. We're talking about increased reliability, reduced costs, and a more sustainable energy future, all thanks to machine vision.
Fewer blackouts, lower bills, and a healthier planet. Sign me up. Hey, that makes me wonder, if machine vision can do this for our power grids, what other systems could it transform? Could we use it to monitor bridges, roads, or even pipelines for potential problems?
Now, that's a question worth exploring.